Unity terrain looked like this. So instead, I use a custom terrain system that offloads most of the work from the CPU to the graphics card. This optimizes performance, which allows me to amplify the detail to half a meter or better. To see how this is done, let's start with how terrain gets its shape. First, we need a mesh with a set of points called vertices. If you hand the graphics card a grayscale image called a height map, it can efficiently displace each vertex according to how bright a corresponding pixel is. Brighter pixels rise more, darker pixels rise less. Hand it a realistic height map of terrain, and you get realistic displacement. But rendering all of this data at once would be inefficient, seeing as you only notice a high level of detail when you're close to it. So what virtually all terrain systems employ is a level of detail system. This approach uses a quad tree, which cuts the terrain into 4 patches, and then cuts those patches into 4, and so on, increasing resolution depending on factors like where the player is, and how much detail a given patch would lose at a lower resolution. Another optimization is to only draw the terrain that the camera can actually see, a process called frustum culling. A frustum is just the shape you get when you cut off the top of a pyramid, and you can use it to represent the total space a camera can see given its field of view. Quad trees and frustum culling can be all you need for terrains of small or moderate size, and they're built into most game engines. But this terrain has detail down to half a meter, and on this map there are over 15,000 square kilometers to represent at that resolution. So at this scale, it begins to matter who is running these optimizations.